Hello, Arya. Are you connected? Will? Okay. Arya, are you connected? So let's start. आवाज शायद आवाज म्यूट किया हुआ है. Hello, are you getting?
Yes, sir.
Actually, sound was mute. Fine. So we have to go for today about line integration, especially here. And as far we have discussed about the vector integration, that is the indefinite and definite integration, right? Besides, we have already discussed about these all theorems, and in these theorems, we are using curls, gradients, and divergence. On this basis, we have to go for some numericals also, although later on we'll discuss some numericals. If you want, I can discuss some numericals too over here right now, either or directly. Let's go for line integral. What do you wish?
Line integrals and
Line integral directly. Okay, fine.
yes.
Later on, we'll go for this all numerical settings. Fine. So let's see about here the line integral. So as far we have discussed about the basic idea of line integral. We are okay, fine. Let's see. So uh, the topic is line integral. The basic difference between simple integral and line integral is that what do you say here? That it mean can modify over here. That okay. So first we will go for some basic concepts that we say. What about this curve? That we say one of the curve is called oriented curve. Oh, you should know that. What is oriented curve? As you see here, let this point be A and this point what we call B, right? So if we go like this way in from A to B, that is this A, this is the position in the space of this point A, and this is the position of B in space somewhere. Let any coordinate x1, y1, z1 coordinate and x2, y2, z2 coordinate is there, and we are going along with this curve in this direction C, right? So let C be the curve in a space from A to B. This is such a curve is called oriented. It can be oriented by taking one of the possible two directions as positive. Okay? If the direction is from A to B, if we are saying if the direction is from A to B, and we consider positive, you have to assume positive. Then while coming from B to A on the same path or in any way else, then this is called negative, right? The path should be coincide. Is this okay? So from B to C, somehow if we are going to somewhere else, then the path is here. We call B to A from some else position also, then it is negative. But if the initial point is A, suppose, and the terminal point B coincide, then the curve C, suppose this point A, let me take this point A on this here. We can go like this one. Suppose just let me make one more diagram. Suppose let this point be A over here, and we are going like this way, and we are coming in the closed loop like this, and the end point is once again B, that is same, right? We go from A to B, and we are B and A, both of the points are coinciding. So such curves are called like this. If we are going like this way, better just to consider like this way, so that avoid confusion, like this, and we are coming like this way along this curve C. Then such curve is called closed curve, right? This curve is called closed curve, and such curve is known as oriented curves, right? Acha, it's all okay for this, but what about smooth curves? Let's see smooth curves. First, we have to clear the concept of smooth curve. Let the curve C represent. Let the curve C represent by parametric equation, by some parametric equation. Parametric equation, let's say x equal to x dimension is along with some x comma t function, and y is some another function y of t, and z is some another, let t be the parameter, t be any real parameter, right? So then each point on the curve, then each point on the curve, on the curve r of t, when we consider a vector relay, then we say xt of I unit vector, right? Means on the curve, on any path what we consider, whether it is closed or whether it is oriented, suppose some point is there. So from origin, the position of this point, that is governed by rt vector, position vector, that is xt of I, and plus y of t of j unit vector, plus z of t with k unit vector. It's okay. A curve is said to be smooth if the function is, when it will be smooth. A curve, what will be the condition? Do you know? A curve,
Differentiable.
yes, continuous also. Before that, continuous also. A curve is said to be, said, correct. If the function is differentiable, then undoubtedly it is continuous, right? If the function
Yes,
is differentiable, then undoubtedly it is continuous. Function be continuous and well differentiable too. So a curve is said to be smooth, correct? So let me write here smooth if the function rt is, if the function r of t in the vector form we have to write is continuous, is actually we have to write like this way, is continuous why I am writing like this, just you will get another, after another, you will get the idea. Continuous um, and has continuous and has continuous first derivative and has uh, means a function is said to be smooth. This is what I've written. RT is continuous and has RT is continuous and has continuous. Yes, you can write continuous. Continuous means just point पे continuous होगा and continuous first derivative. RT is continuous and has continuous. Um, that is first derivative. You know, first derivative. First derivative. First derivative क्या होना चाहिए? Not equal to zero. Not equal to zero. So that critical point नहीं होगा. Means stationary point shouldn't be there. Clear? Are you
Yes,
getting? As continuous first derivative not equal to zero for all values of t. For all values of t. छोटे छोटे क्वेश्चन यहाँ पे बन जाते हैं, ठीक है? There is a unique tangent I, that is, इसका मतलब क्या हुआ? Geometrical significance इसका ये है. There is a unique tangent. There is a unique tangent. Unique tangent at each point on the curve. At each. वैसे फंक्शन में तो यूनिक टेंजेंट होते ही हैं, बट कर्व में यूनिक टेंजेंट नहीं होते. कर्व में मतलब एक ही पॉइंट पे एक से अधिक टेंजेंट भी बन सकते हैं, राइट? सो देयर इज अ यूनिक टेंजेंट एट ईच पॉइंट ऑन द कर्व. एट ईच पॉइंट ऑन द कर्व. C. Correct. So piecewise smooth curve. अच्छा, sometimes वो अगर function not derivable है, just like suppose like this way, ये ऐसे बन गया, suppose फिर ऐसे बना दिया. जहाँ भी sharp corners रहेंगे ना, तो function not differentiable होता है, clear? और फिर ऐसे बना लिया, like this way, and फिर ऐसे बन गया, like this. अब ये तो function ही exist नहीं करेगा, तो थोड़ा इसको और चेंज कर देते हैं. जैसे मॉड फंक्शन है एफ एक्स इक्वल टू मॉड एक्स, राइट? लाइक दिस एंड लाइक दिस, लाइक दिस. सो यहाँ पे ये स्मूथ होगा, यहाँ ये स्मूथ है, ठीक है? फिर यहाँ भी स्मूथ है. इस इंटरवल में, यहाँ से इस इंटरवल से इस इंटरवल में, तो यहाँ पे स्मूथ हो जाएंगे कर्व्स आर स्मूथ, राइट? सो इफ यू से हियर, लेट मी नेम ओवर हियर ए बी C, D and E point. At B, C, D, function is not differentiable, you say, right? So this one is curve is piecewise smooth curve because it consists 1, 2, 3, 4 pieces of a smooth curve. So AB is one of the smooth curve, BC is another smooth curve, CD is another smooth curve, and DE is another smooth curve. These are the, you can say, piecewise smooth curve, right? Let me recall here that this is piecewise smooth curve. So let me write piecewise smooth curve, right? So piecewise smooth curve. This is piecewise smooth curve. Okay. So no need to write definition. A curve is said to be piecewise smooth if it is composed of finite number of smooth curves. Finite number of smooth curves. These are the smooth curves, right? Clear? So, you know, okay. So let me say here, just like AB, BC, CD, DE, if we make the rectangle idea here, means the rectangle consists of these four pieces of smooth curves. Then that is means let me explain here for line integral. Let me write the heading line integral. Now we are able to understand line integral because we have to go on these curves only, right? Line integral. Okay. So look at here. Right. So the definition of the line integral will be, although I have given the definition, let me write once again. The integral, hmm, which is carried on a curve, which is which is carried carried on the curve, carried on the curve is called is called line integral. Line integral, you can say. Okay. So that it means you have to write like this way. For this curve, we can write C over here, and that we say f dot dr. Although we are considered here linear integral linearly, so in the linear order, r behave as xi plus yj plus zk. So on the curve, you know, on the curve, we have to go for on the curve. On the curve is here important. That is on the curve. So on the curve, you see that is only one variable is independent. You have to mind this point. And the other two variables means we consider x, y, z. Then other two variables are means they are independent variables. Okay. So other two variables are dependent. So only one variable is independent. Only one variable is said to be independent. Is independent. Independent. Right. And the other two variables will be dependent. And other two variables, two variables is independent. Sorry, independent. Other two variables is dependent. Only one variable is independent, other two variables you have to write dependent. Dependent variable. Clear? So if we see here, as like in work done, we use f dot dr. So if we say f vector, f is any vector, and let's say its x component is along with the any function f1. So f1 into let's write I unit vector, right? So we see over here f1 into I unit vector plus f2 into j unit vector plus f3 into k unit vector. Okay, and r vector is equal to, let's say, xi plus yj and plus zk unit vector. Correct. So similarly here you can write dr vector. What you can write? That is dxi. Are you getting about dr dxi? How? Plus means along with this x component, whatever the curve is going on. So along with the x projection, that is the change in the x, that is dx, means x to x plus dx. We have to go for that, right? And then dy into j unit vector and dz into k unit vector. All is there. Just wait, no down. Hello? Yeah, Raju speaking. Please, you call later. Uh, आफ्टर एन आवर मैम 1 घंटे बाद कॉल कीजिए अभी क्लास में हाँ ठीक ओके तो ये सुनना है so then f dot dr what we say here then f dot dr vector that we say f1 into dx are you getting dot product of these two vectors
Yes.
f1 dx I to I j to j k to k and here
Yes.
that is f2 dy I will explain this also later in geometrically pattern don't worry f3 dz first let me make the formula like f3 dz okay where f1 f2 f3 are the functions of along x where f1 comma f2 comma f3 are the functions any of the functions according to as per problem are the functions and situations are the functions of x y z are the functions of x comma y comma z right so conclude over here one of two of three of the functions of you can say over here that is let me just run on here f1 f2 f3 like this f1 f2 and f3 okay so let's see over here so I'm writing like this yeah so these are the functions here one two three here you can see and now you say f1 f2 f3 are f3 are the functions of x y z respectively and according to as per that you have to integrate sometimes the question may be like this way here if we take x as an independent variables here and y and z can be expressed this in terms of x using the equation of the curve according to as per situation just like suppose you say x is let's say x is independent variable you can consider any of them independent variable so if as I have written over here any one of them is that is independent variable and the other two variables are dependent so let's say x is independent variable here okay and y and z are dependent variable y and z are here we have considered that dependent variable you can change this also according to as per the definition what is provided over there so if y and z can be expressed in terms of x let's say that is y equal to any function gx let's say and z equal to because z is dependent on x So z is equal to, let's say, any function, let's say hx. Okay, so what do you say here? This provides, so differentiate, you can make it dy is equal to g dash x dx, can be write like this way, and this implies that we say dz is equal to, that is h dash x dx, can be write like this way. So once you get this idea, then now you say f dot dr. What about this one? That is f dot dr, that what we have to evaluate over here, as you see f dot dr. So f1 dx, f2 dx means question you have to do like this way. So that what we say here, f1 dx, you have to write like this way, f1 dx as per previous, you see here f1 dx plus, now for f2 dx, f2 as a function of y you are saying over here. So f2 dy and f3 dy, first let me write f2 dy and f3 dz can be written as f3 dz. Now this can be expressed, means you can say this will be reduced to fx. So the line integral, this will become, what do we say here after writing this all? So for this will be reduced to fz dz as f2 dy, f3 dz. So for f2 means this y, you can use this dy as g dash x dx, and for this one like this way, right? So the line integral will be means you can say in other words, that is directly I am writing over here, c, that is f dot dr over the line integral, that we say reduces to a simple integral. You can say here z1 into z2, that is you say fz dz, whatever the function will be, right? Whatever the function will be, means if it is in terms of x, then fx dx. So which can be solved by using usual technique, जो इंटीग्रेशन की जो सिंपल मेथड्स होते हैं ना, जो भी बाय सब्स्टिट्यूशन, इधर बाय पार्ट्स या जो भी होगा, उसको स्प्लिट कर लेंगे. अच्छा, समटाइम्स इक्वेशन इज लाइक दिस वे, समटाइम्स इक्वेशन ऐसे दे देते हैं. ये बात समझ में आई ऊपर वाली आपको?
यस सर.
ये मतलब कहने का कि ये जो चीज़ें हैं, आप मीन्स जैसा भी सिचुएशन हुआ उसको आप इस पार्ट में स्प्लिट कर लेंगे, राइट? जैसे अगर हम लोग सपोज x के फॉर्म में ये बना रहे हैं, तो अच्छा इसमें सॉरी किस होना है, x इंडिपेंडेंट वेरिएबल है, तो सब चीज़ x के टर्म्स में स्प्लिट हो जाएगी. ये मैं z लिख दिया, ये तब रहेगा ना किसी एक वेरिएबल में आ जाएगी. हम लोग x में रखें तो ये x1 टू x2 जो भी रहेगा वो पॉइंट x1 टू x2 और dx ये x1 टू x2 और ये fx dx हो जाएगा. ये चीज़ समझ में आया कैसे हुआ? f2 वाले भी ये फंक्शन ऐसे ही आ जाएंगे, ये y के जहाँ जहाँ आप देखो y, वहाँ वहाँ gx सब्स्टिट्यूट कर लो, जहाँ जहाँ z देखो hx, यानी पूरा फंक्शन x के टर्म्स में आ जाएगा. क्लियर? और अगर हम लोग सपोज वेरिएबल चेंज कर दिए लाइक दिस वे, पहले तो मैं यही चीज़ बता देता हूँ. चलो लेट मी एक्सप्लेन दिस प्रॉपर्ली. इसको भी हटा दो, इसको हटा दो. तो पहले तो ये आ गया. अब जैसे कि इसी रिजल्ट में ये वाला रिजल्ट, ठीक है, तो जो f डॉट डी आर है अपने, मैं क्या किया हूँ f डॉट डी आर, तो दिस विल बी रिड्यूस टू लाइक दिस. तो अभी इसी को कॉपी कर लिया जाता है, ठीक है, देखने को. अब जैसे ये चीज़ मैं कॉपी कर ले रहा हूँ और इसी से चेंज कर दूँगा, ठीक है. अब यहाँ तो वो x इंडिपेंडेंट वेरिएबल है. अब हम लोग क्या करेंगे, इसी को y को इंडिपेंडेंट वेरिएबल बनाएंगे, ठीक है. अब यहाँ पे क्या कर रहा हूँ मैं, यहाँ पे थोड़ा चेंज कर देते हैं. अब यहाँ पे एक अनदर वेरिएबल को, ये डिपेंड करता है आप पे कैसा सिचुएशन दिया हुआ है. y इंडिपेंडेंट वेरिएबल हो गया. अब हम लोग क्या करेंगे, x और z को डिपेंडेंट वेरिएबल बना लो भाई, ठीक है. तो x और z को डिपेंडेंट वेरिएबल बना लिया. तो x और z को डिपेंडेंट वेरिएबल बनाया, तो अभी क्या मिल जाएगा, ये देन x इक्वल टू, यस, तो अभी सभी लोग को y के टर्म्स में लेके आ जाओ, ठीक, सभी लोगों को y के टर्म्स में लेके आ जाओ। अब इसको करते हैं, सभी लोगों को y के टर्म्स में। अब देखो y इज इंडिपेंडेंट वेरिएबल, x एंड z आर डिपेंडेंट वेरिएबल, तो x को अब हम लोग क्या करेंगे, लेट्स से g ऑफ y अब बना लेंगे, और z को क्या लिखेंगे, h ऑफ y, करेक्ट। अब सबको y टर्म्स है, तो dx इक्वल टू क्या हो जाएंगे, g डैश y dy, और dz इज इक्वल टू h डैश y dy। नाउ these all the results will become in terms of y, you know। तो अभी क्या अगर हम लोग देखते हैं यहाँ पे, ये वाली जो चीज थी अपनी, दैट इज एफ डॉट डी आर, ये वाला रिजल्ट, ये वाला जो रिजल्ट है, तो एफ डॉट डी आर, दिस रिजल्ट, सो दिस रिजल्ट विल बी रिड्यूसेस टू, अभी हम लोग यहाँ पे ये रिजल्ट कहाँ पे रिड्यूस हुआ, x1 टू x2 fx dx, तो अब ये रिजल्ट किस में रिड्यूस हो जाएगा, y के टर्म्स में रिजल्ट रिड्यूस हो जाएगा, ओके। तो अभी ये रिजल्ट y के टर्म्स में रिड्यूस होने वाला है, तो दिस रिजल्ट विल बी रिड्यूस्ड इन टर्म्स ऑफ, so this will be, this will be reduced to fy dy, fy dy हो जाएगा, ठीक है। अब fy dy हो जाएगा, तो अभी कैसे बनेगा, मीन्स सो द लाइन इंटीग्रल, सो द लाइन इंटीग्रल जो हम लोगों की रिक्वायर्ड है, लाइन इंटीग्रल, हम लोग कर्व पे से जा रहे थे ना, कर्व पर किस कर्व पर से जाते हैं, सी कर्व, जो ओरिएंटेड कर्व जो भी है आपका, एफ डॉट डी आर, सो दैट व्हाट वी कंसिडर हियर। तो अभी y1 कोऑर्डिनेट ले लेंगे, y1 कोऑर्डिनेट लेंगे, सो वी हैव टू कंसिडर y1 कोऑर्डिनेट एंड देन fy dy, देन वी हैव टू गो अलोंग विद fy dy। आर यू गेटिंग? जैसे अभी प्रीवियस केस में हुआ क्या, we have converted entire y and z variable in terms of x, and then we are
Yes, sir.
evaluating in terms of x only, because x was independent variable. Now the same situation is there, that is y independent variable, and xz we are converting in terms of y, and now we have to evaluate simply in terms of y, and then simple integration technique that you have to do over here, right? Are you getting? And same process that what we have to do, once again you can see over here the same process here, you can go like this way, that if you consider entire this thing, then let me change over here once again. Now look here, as here y independent variable is there, now we have to consider as z independent variable, right? Mean that what I am saying over here, then you have to consider any one of the variable, and here then you have to consider the rest two variables are along with that dependent variable you have to consider, right? So let's see over here. So let me check, you have to eliminate this so that we will go for dz. Yeah, so now the z is independent variable and x and y are independent variable. So x to be considered, x is dependent on z, so you have to consider any of the function, not only g and h, any of the letter, you can say f also, x also. So that is x, and here that is y is in terms of z. So that is what do you say here? Dx, differentiate dx, g dash z dz, and h dash z dz, and here that is dy. Is this all right? So this will be reduces in terms of fz dz, and that what we have written over here, that is line integral will be, what the line integral will be there. If you see the previous slide, that is the line integral, this part will be reduced to fz dz, and here then it means it reduced to is f dash z dash, f z dash, reduced to fz dz. Means integral of, yes, integral of means that is z1 to z2. z1 to z2. In the previous, what I have written over there, here, that is x1 to x2, right? And then after, what I have written here, y is independent variable. Then you have to go for y1 to y2, the integral reduced to y1 to y2 fy dy, right? So fy dy, this will be reduced to fy dy, and this will be reduced to acha. So that is not for this. This reduced to fz dz, and then we have to go for line integral. So the line integral. So the line integral integral of c into that we say f dot dr vector, that is converted to integral of z1, means you have to consider z1 z2 coordinate fz
Yes,
dz.
sir.
Hope so you are getting. So this is the one part. Sometimes the equations are in terms of parametric form, right? Then what do you have to do over here? Let's say sometimes the equation, is this okay?
Yes, sir.
Are you ready? Yeah. So let me take a quick revision what I have taught over here. In the line integral, we have to go along with the curve. Means let this point be x1, y1, z1 coordinate, and here let's say this coordinate is x2, y2, z2 coordinate. x2, y2, and z2 coordinate. Let's say x2, y2, z2 coordinate. And we are interested to find the integral along with this line. So you can go either on x independent variable, y independent variable, or z independent variable, and rest of the two independent variables you have to check which type of functions are oriented over there according to as per convenient given in the problem. So in the problem, the function is given in terms of x only, sometimes x and z both. So you have to reduce such a way and resolve these all data such a way that all the functions comes in terms of any one of the variable. So x, y, z, you have to consider any one of the variable as independent and rest two variable as dependent. So you have to consider that particular ordinate which you are considering as an independent variable while integrating. So if you see over here, so and these all occurs in only piecewise uh, continuous function, right? So smooth curve. So in the smooth curve, the line integral goes like this way. So f dot dr, just like here we have to integrate this along with this curve. So we can come for x1 to x2 fx dx. Rest y and z function rest y and z variable converted with the help of the function given in the question as gx and hx, like this, and differentiate. Similarly, go for y and z variable also. But sometimes it is given like in the piecewise function parametric form. In the parametric format, then what you will do like this. Let's see. So sometimes the question occurs like this way. Question maybe in question they ask like this way. Sometimes, let me write sometimes. Sometimes the equation of the curve given in parameters, the equation of the curves of the curves given in parameters, right? So parameters are parameters may be t, means parameters x, y. Sometimes the equation of the curve given in parameters x, y, z in terms of t, in terms of, you can say, t, right? Parameters expressed in terms of parameter t. So using parametric equation क्या हो जाएंगे? Let's say parametric equation. Parametric equation में फायदा रहता है कि you can convert all the variables in a single variable, single new arbitrary variable. So x, y, z, you can consider any of the function g1t, right, and g2t, and z equal to, let's say, g3t, be any such function. And this implies, after differentiating, wherever you find dx, then you have to go for g1 dash p dt, right? and all the functions converted in terms of t parameter, that is g2 dash t dt, and then what we say here, dz is equal to g3 dash t dt. Is it okay? So for this f dot dr, what you will do? F dot dr will what happen? That will become f1 dx.
T1
Yes,
into
yes.
T.
F1 dx, and then we say plus what we have written earlier, dy, and plus f. Sorry, f2. That was f2. So let's say it's fx, x component, y component. So let's say f2 was your y component. So let me write here f2, and here that is f3 dz. F3 dz, okay, will be reduced to, will be reduced after these all substitution, will be reduced to which type of pattern, that is FTTT. FTTT, as like in the previous you see, they were reducing in terms of Fy dy, they were reducing in terms of Fz dz, right? So here they are reducing in terms of FTTT. FTTT. And the line integral, so the line integral, so the line integral, will become like this way. Integral of c, that is f dot dr, f dot dr reduces to reduces to simple definite integral, simple definite integral, and that becomes, that is integral of t1 to t2, you know, t1 to t2 means t1 and t2 are the corresponding parametric points, right? As x, y, z was there, by the help of that substitution you can find t1, t2 also, ft dt, right? So whatever the boundaries are there, which can be solved by using usual techniques, that is. So means there are how many ways solving the line integral by converting it into definite integral? There are 4 ways you can say. One of them is parametric form, and rest 3 of them are converting in any one of the variable x, y, z. Right. So let's go ahead with some questions, and let's we try this technique and we use how to handle the problems. So maybe, so let's take a question. First, question number 1. On the line integral, today we'll discuss question. If vector f is equal to, suppose f is any vector, and that is 3xy, any of the variable I unit vector, minus y square j unit vector, determine the values, determine question is given, determine the values of integral of c, that is f dot dr, where c is the curve. Look here, where c, this c is the curve, that is a parabolic curve, curve, that is y equal to 2x square in xy plane, from the point is also given over here, 0, 0 to, I am considering only in 2 dimension, 1 to 2, right? So what do you think about this? How to tackle this? Whether you want to do, or let me explain first. May I explain
Doing
it?
it, sir.
Huh?
Doing it. I'm doing it.
Achha, you are doing. Okay,
Yes.
please go ahead. Although I am drawing here, that is the 3 dimension. You can see over here. The question is, it's okay. Just try. Just, let's say this is x-axis. This is what we call y-axis, and let's say this is z-axis. So we have to go from 0, 0 point. On xy plane, we have to consider the curve like this. The curve is along this y equal to 2x square, this one, and the point is here 1, 2, right? And we have to go along with this curve. So it's pretty easy. What you will do, y equal to 2x square, just differentiate here.
Yes, sir. Dy
Yes.
equals
4x
to
dx.
4x dx.
Correct? And then go ahead integrating as f dot dr.
Converting.
Yes, f dot dr. Yeah, convert this. All converted in x variable, right? So as 3xy function is there, and dx minus y square dy. Actually, this function is given here, and according to as per curve. Now, wherever the y is there, you substitute this as 2x square because we have to go for in x independent variable as well. So 3x, and here for y that is 2x square was given over here. Y is 2x square, substitute. So that it will be 6 now.
6x cube.
6x cube, correct. So that is 6x cube dx, and minus for this y whole square, that is 4x to the power 4, and that is, no, sorry, 4x, yeah, 4x to the power 4 besides dy is equal to 4x dx. So that we say 4x dx. Yes, later on 16. So finally, what do you say here? 6x cube minus 16x to the power 5, right? And that dx is common. Now it's very easy to integrate, and simple integration is there. And that is the only difference between line integral and simple integration. Now this is the question of simple integration, and you can go ahead for this. Now, which limit you have to put? You have to consider the x limit, means x coordinate. So 0 and 1 you have to consider. What do you have to consider? 0 and 1, right? So from 0 to 1 you have to integrate. So the line integral, what do you write? So the line integral can be managed like this one. Line integral. Actually, line integral are along with the curve. Integration along with the curve, right? And what geometrically signifies, I have already shown in the previous that one from GeoGebra site. I have shown you. I can show this also. This type of functions what we are evaluating. I can show this also. Don't worry. I will show later on. So the line integral 0 to 1, right? 0 to 1, that is simple integration, 6x cube minus 16x to the power 5, okay, and dx. Now nothing to do over here, simple integration, 6x to the power 4 by 4, you can say. Is this right? And that is from 0 to 1, you can say over here, minus 16, that is x to the power 6 by 6, correct, from 0 to 1. Now integrate it, and what we say here, that is 6x to the power 4 by 4, 1 by 4, 6 by 4, and 16 by 6, because that will be 1. So 8 by 3, and here, better just let it be 6 by 4. Okay, 6 by 4 minus 16 by 6. So take an LCM, 24 and 6. What is the answer? That will be 6. So now the result will be minus 7 by 6, because this one is greater. Clear?
Yes.
Fine. Okay. So this This is the answer. So if y is taken as independent variable, then how you will tackle this question? If you take y as an independent variable, suppose in the same question, if I say if y is taken, although we have to put over here x independent variable just for sake of convenience, but if I say that you consider y, if y is taken as independent variable, independent variable, yes, then variable, then what you have to do, as y is already expressed in terms of x square in the question, then you have to express x in terms of y. What do you have to do? You have to do express x in terms of y. You have to go ahead. You have to do like this way. Express x in terms of y. Right? So now express x in terms of y, what you will get? X equal to, as y equal to 2x square, so x equal to y by 2 under root. So x equal to, what do you say? Under root y by 2. Let's see whether you are getting same result by doing this or not. Let's see. So x equal to root y by 2. This implies dx equal to, what is the differential of root y? Root y differential is 1 by 2 root y. So 1 by root 2 you say like this way. And here that is 1 by 2 root y. So better write like this way, 1 by 2 root of y. Are you getting differential of y? So that we say here, f dot dr, f dot dr, what you will write over here, that is 3xy dy was there. What was that? 3xy dy minus y squared dy. 3xy dx was there, sorry. Remember to convert this. Dx and then minus y squared dy. Okay. This is given in the question. Now, what do you have to do? 3x, not x. Now we are considering y as an independent variable. So we have to eliminate x. So for x, we have to say root of y by 2, root of y by 2, and y as it is. And now dx will be converted with this entire thing. You have to convert this dx and entire thing this, right? Like this. So here you can say dx. This is dx. Are you getting? This I am writing for dx. The same thing. Clear? Is it? And what about this one? Minus. Hello? Are you connected?
Yes, sir.
Okay, fine. So minus y square dy. Okay. And then, yes, then after what happened? So let's see, let's say where it is related. So root y is related with this root y. Root 2, that will become 2, 2, 2, 4, and that is 3 by 4. And that is 3 by 4. Root y already related, on the only we left over here with y dy. Y dy minus what about this one? That is y square. So better just you can take out common over here. 3 by 4 minus y square dy. 3 by 4 y, you better write like this way, y square, and that is dy, isn't it? So now we are reduced in terms of y dy. So the result will be, so the line integral, that is c f dot dr, whatever that is, capital F, perhaps we have assumed over that. So you go like this way, capital F dot dr, and that will become the integral of, that is, now you have to consider the limit in terms of y. What limit you have to consider now? Now you have to go for 0 and then for 2, right? Then you have to go for 0 to 2. So 0 to 2. Are you getting? Y1 to Y2, that's corresponding values you have to go for. That is 3 by 4 of y minus y square dy. Now integrate simply. Now it is a simple technique integration, that is 3 by, what do you say, 4 to, that is 8. So that is equal to 3 by 8y square. Are you getting why 8? Y square by 2. So that is 8, 4, 8 minus, that is y cube by 3. It's okay. From 0 to 2. Upper limit minus lower limit. That we say. You see over here. 2, that is 4, 3, 4, 12 by 8. And that is 8 by 3. So you say here 12 by 8 and minus 4, 2 cube, 8 by 3. You can see over here. So like this, you can say 3 by 2 minus, that is 8 by 3. 3, 3, 9 minus 8, 6. 9 minus 16. 9 minus 16 by 6. That is minus 7 by 6. Minus 7 by 6. Is this alright?
Yes.
Are you getting? That is the same minus 7 by 6. You can see over here. So that was the x and y variable over the was there. And in the similar manner, you can go add some more questions over here. So let me give one more question. You please do this and try, and then we'll switch to the new concept. So let's see over here for some another pattern. This, although question is same type, or we switch on another concept, or we take one more problem. What do you want? You will do it. Let's take one more problem. Under the curve, f dot dr, right? And here where capital F is equal to, let's say, x square minus y square into I unit vector, right? And plus xy into j unit vector. And the curve C is along with the curve, let's say same. You can say and curve this C, okay? And the curve C is arc of the curve, y equal to, let's say, x square from 0, 0, from 0, 0 to, let's say, 2, 4. 2, 2. Now, you just please try. You can convert any one of the variable, whatever you wish. It's better as the y equal to x square given. Whatever you wish, you can go ahead. That same, that is, let's say, that we say x axis and y axis over here. This x axis, this as you see here, y axis. Recall the curve, that is the same like this here, that is 0, 0. This is x-axis, that's what we call y-axis. This we say 2, 4, and here along with this curve C, right, from 0, 0 to 2, 4. Yes. Now try to do this. Yes. So what do you want? You want to take independent x variable or y variable? What are you doing? F dot
I've taken dy, sir.
F dot dr
X as the independent.
x square minus y square. What the answer will be? Declare the answer. Dx plus.
Integral I've gotten as 2 x raised to 4 minus 3 square. I'm integrating from.
So now integrate from 0 to 2 you have to integrate. Y equal to, what is given as x square. So dy equal to 2x dx. That is f dot dr. There's nothing to do over here. It's pretty easy. What do you got? X square minus y square dx, right? And for this y square, you have to subtract x square. So you have to say x power 4. You just put the value of y over here. You will get x to the power 4, x square whole square, right? And then what we say here, plus xy dy. Okay. So x as it is, and for y that is x cube. So finally, what do you say here? X cube, because x square into x. And for dy, once again, one more, that is 2x and dx. Right? Okay. So you can go ahead and do like this way. And then integrate. What is the answer? So finally, what do you get after solving? X square and plus x to the power 2x to the power 4 and minus x to the power 4. So that will be x to the power 4. Are you getting?
Yes, sir.
So the line integral C f dot dr. That it means you have to go for integral of 0 to 2 because we are considering x variable. So we have to go mind the x coordinate, right? So 0 to 2, and the meaning of this is here x square plus x to the power 4 and dx. And now it's pretty easy. X cubed by 3, and then after only calculation is there, x to the power 5 by 5. And here that is 0 to 2. It's pretty easy, isn't it? What do you found? Answer 8 by 3 plus 2 to the power 5, that is 32
32 by 5.
by 5. And this is 3. So that is say 15, 5 at 40 plus 5 3 15, 5 2 10, 60 and 160, that is negative. Sorry, 3 is there. 3 9 3 2 6 96 136 by 50, and that's your answer. Yeah. 96 5 at 40 40 96 136 50. Correct. That is your answer. So in the same manner, you can go and do some more problems over here. I can give you some more problems also. Achha, suppose sometimes they ask like this way, that here the applications are evaluating force. So suppose force acts on a particle and particle is displaced along the path, along a given path. So the work done by the force is given by line integral. Work done, entire work done is given by the line integral. So work is equal to, you have to say, integral of C. This is an example, you can say. This is also an example. So f dot dr along with this curved line path, right? So the integration is being carried in the same sense of displacement. It's okay. Yeah. So let's take a question, one more, third question. Find work done. Find work done. Find work done when a force, let's say force, let's define the force, 1 x square minus y square plus x under bracket into I unit vector and minus 2xy plus y into j unit vector. right? And moves a particle along with this force. Find the work done when a force F moves a particle, moves a particle in XY plane, in XY plane from you know 0 0 to 1 comma 1 comma 1 along the parabola. Along, it's easy to take this parabola. So usually they gives the question parabola, although they can be made on any line, exponential curve also, cubical curve also, but along uh, the parabola. The parabola is y square equal to x. Along the parabola, y square is equal to x. Yes, try to solve it. What is the work done? Are you ready?
Yes, sir.
Yeah. So once again, same analogy you have to go for. Now here, better just you can convert this all in terms of y also, because here there is, you can see only one odd power is there, and x one power is there, and x for everywhere x you can substitute y, and that will be also easy rather than substituting and going make a root of x, because y square is equal to x. So it's better just convert in the independent variable y. Consider y as an independent variable and x as a dependent variable. Now you can consider x as a dependent variable and y as an independent variable. Although whatever you find the facility you can do over there. But prior to this, you differentiate this also to convert this dx in terms of dy. So see here. As x is y square given here. So first 2y dy. You can note on like this way. So work done in moving the particle in displacement, our dr is dw, you can say, that is f dot dr. Achha, this line integral, this is performing according to as per, actually work is a scalar quantity, so the dot product is required over here. So that what we are doing over here, that is x square minus y square, f was given over there, okay. X square minus y square plus x, and plus x dx, you have to recall, because for dr you can say dxi plus dyj, and that is here you see 2xy plus y, so that is minus 2xy, and that is plus y, and here that is dy. Okay, so what do you think about this, how this minus comes due to this negative? Are you ready?
So the integral that I got was
Yeah, now
2y raised to 5.
Acha, you are getting
2y,
the result 2y to the
yes,
power, yes,
5
5
minus
2,
2y raised to 3
yes,
minus y dy.
correct. So now if you get this result on substituting x equal to y square and wherever dx you find, that is 2y dy you can put over here, this you can put over here, and then simply integrating this in terms of y. So for w, that what we have to go for integration from, what the limit you have chosen over here, 0 to
1.
yes, that is, yeah, 1 comma 1 is there. Although you have to consider y ordinate limit. So 2y to the power 5 minus 2y cube and minus y dy. It's okay, and that is the result. You can evaluate this. 2y power 6 by 6 minus 2y power 4 by 4. You can do over there. Y square by 2, 0 to, and then simply integrate. What is the answer?
Minus 2 by
Minus 2 by
2 by 3.
Correct. That's the answer. Answer is correct. Minus 2. Fine. Acha. So along with the circle, where the closed loop is there, for the closed loop you can make a circle also, integration of a circle. So that's a question of four. Evaluate. Suppose if we it is given a evaluate integration over circle. Although circle you can make an arrow over here. Sometimes they make. So x dy minus y dx. Then what they are asking around a circle. Say around circle. Okay, that is x square plus y square is equal to r square. Okay, now you try, please. Around a circle, x square plus y square is equal to r square. Evaluate this. And what did it mean? How to do this? Let's see here. Let's say this is x-axis and this is y-axis. Okay, so let's say this is x-axis over here, and this is what we call y-axis, and the equation of circle is x square plus y square is equal to r square. Okay, so here what do you have to find? X dy minus y dx around the circle. Let C denotes the circle. This one, C is the curve. So, here the parametric coordinate will be, let's say this is R is the radius of the circle. So, the parametric coordinate you have to select as R cos theta, you should know well, R cos theta and R sin theta. Isn't it?
Yes.
This is the parametric point. So, in this situation, you have to consider x equal to R cos theta and y, that is R sin theta. And you have to go along with this closed loop, that is entire. So the angle to be considered, the limit from 0 to how much? Entire angle, that is 2 pi.
Yes, sir.
So yes, so here you have to consider the parameter theta. Theta varies from, that is less or equal to 2 pi and greater or equal to 0. Start from 0 to 2 pi. So you know that is x equal to R cos theta. This implies when you differentiate here, what you will say? Dx equal to minus R sin theta. Differential of cos theta is minus sin theta and d theta. And here differential of sin theta, that is cos theta. So dy you say that is R cos theta into d theta. Is it clear? So now you know that is x dy. What do you have to evaluate over here? That is x dy minus y dx. This part, correct? So this part you have to say here. So evaluate this as x dy minus y dx, and that is, you can recall here that substitute the value over x as r cos theta. So and dx for this one minus r sin theta. So finally, what do you get here? R cos theta for x and for dy, that is r cos theta d theta. r cos theta once again, that is same, d theta for this dy. For this dy, I am writing over here and minus as minus with this one, and r sine theta. Let me substitute this value clearly here. This one, okay. This is for x, this is for dy, and this is for y. And what about dx? Dx is minus r sine theta d theta, r sine theta d theta. Is it all right? Is it okay?
Yes, sir.
So right over here, minus r sine theta d theta. Correct. Now multiplying this all, what do you say here? That is r square, right? And here it will become cos square theta, and minus minus that will become plus r square sin square
Sine
theta.
square.
And cos square theta plus sin square theta, you should know well, that is 1.
1. Yes.
Correct. So for this over here, so for the integral over c, you can say, you can write like this way either, or you can write like this way either. That is x dy. They have asked here, that is integration of a circle x dy minus y dx. That is means along with the curve. The c means along with the curve. So along with the entire circle, this can be evaluated as r square as it is constant. So integration over circle, and that is d theta. So entire circle, the limit was from 0 to 2 pi. That it means the d theta integral, that is here the answer is 2 pi. So final the answer will be 2 pi r square. So here r is constant because integral is carried over circle. So that is 2 pi r square. Are you getting? You can do some more problem also. I will give the problem, one more problem for homework purpose. Right. Let's say first question. Calculate the work done by force F is given over here, that is xy into I unit vector, and plus that is x square plus y square into, just for practice point of view, I am giving j unit vector moves a particle in xy plane from 1 comma 1 to 1 comma 0 0 1 comma 0 to 3 comma 8, right? 3 comma 8. It is given in the question. 3 comma 8. Along the curve C, that is y equal to x square minus 1. Clear? We can do this one. Clear? One more problem I want to give you. 6, just for practice point of view. Evaluate integration over circle C curve is there. F dot dr, this type we have already studied. F dot dr, where f vector is given as, that is x square plus y square into j unit vector, not j, that is I unit vector. That is here I unit vector, okay, and minus 2xyj minus, that is, let's say, minus 2xy j unit vector, where C is the rectangle in xy plane bounded by, where C जो curve है वो C is the rectangle bounded by right. C is the rectangle bounded by x equal to 0, okay. Then y x squared means the equations are given on the rectangle, that is rectangle by y equal to 0 and x equal to a, and then y equal to, and then x equal to 0. Are you getting? You try. So, means this is a
Yes.
curve along with this, means one of the vertices of rectangle is at origin, and here the curve is like this way, means like this curve, this, and this. So y equal to 0, that is x-axis, and x equal to a, this line x equal to a, right? And here that is y equal to b, this line, and x equal to 0, this line. So means in a circular curve, this is curve here, means there are the four smooth curves, C1, C2, C3, and C4. These curves are there. And then you just evaluate this. 2, 3 more problems we will discuss later on. We'll go for this one, surface integral and volume integral also. Besides, next time maybe we will discuss Green theorem, Stokes theorems, and Gauss-Diamond theorems also. Is this okay? Are you getting? So I'm winding it up.
Yes, sir.
Okay. I'll send the PDF.
Sir, next week I have an exam.
Acha,
So can we not have class next week?
next week on any of the day?
Yes, sir. Like entire week is filled with exam only.
Okay. No issue. No issue.
Yes, sir.
So when you want to attend, you just make a call or you just give the message.
Yes, sir.
Okay.
Yes.